All right, let's jump right in. We're going to decode the pretty complex world of cloud security, starting with who's responsible for what and taking it all the way to a modern philosophy that, well, basically trusts absolutely nothing.
So let's just start with a number to set the stakes. $13.82 trillion. That's the projected global cost of cybercrime by 2028. I mean, that's a number so big it's hard to even wrap your head around, right? To give you an idea, that's more than the damage from most natural disasters combined. The financial threat here is absolutely massive, and it is growing unbelievably fast.
So why is this happening? Well, there's a great quote from Andres Kerr over at Forrester that just nails it. He calls it a perfect storm. And it really is. Think about it. We're shoveling more and more of our sensitive data into the cloud. The environments themselves are getting way more complex. You've got containers, everything's being spun up automatically with scripts. This mix of complexity, all that valuable data, and a ton of automation, yeah, it's created a landscape that is just incredibly, incredibly tough to defend.
And that perfect storm, that's exactly why we're talking about this. Understanding cloud security has never been more critical. The old saying is true, it's not a matter of if you'll be a target, it's when. And more importantly, how ready you are when it happens.
So where do we even begin with all this? It really all starts with one single foundational concept, the shared responsibility model. The whole idea here is that moving to the cloud isn't like dropping your car off to the mechanic and just walking away. You don't get to just hand over all your security worries. It's a partnership. And this model, the shared responsibility model, is basically the contract for that partnership. It draws a really clear line in the sand, spelling out what the cloud provider is on the hook for and what you, the customer, are still responsible for.
Okay, so check this out. What's really interesting here is how that line of responsibility actually shifts depending on the kind of cloud service you're using. Over on the left, you've got Infrastructure as a Service, or IaaS. In this model, you, the customer, are responsible for a ton of stuff, pretty much everything above the basic hardware. But as you slide over to the right to Platform as a Service, or PaaS, you can see the provider starts to take on more of the load. And then, all the way on the right, with Software as a Service, think of things like your email service, the provider handles almost the whole shebang, except, and this is key, for your data and who you give access to it.
So if you take one thing away from this part, let it be this simple phrase. The provider handles security of the cloud. That means the physical buildings, the servers, the networking, all that stuff. But you are always responsible for security in the cloud. That's your data, your users and identities, your configurations. That part of the job never goes away.
All right, so now we know what's on our plate. The big question is, how do we actually build a proper defense for it? Well, it all boils down to a few core principles. First things first, we've got to throw out the old playbook. The whole castle and moat idea, where you build a big, tough wall around your network and just assume everything inside is safe and trusted. Yeah, that's completely obsolete now. It's dead. In the cloud, there is no perimeter. There's no inside versus outside anymore. Your people are everywhere, and your data is everywhere.
So instead, we have to rely on a totally new set of principles. First up is security by design. This just means security isn't some feature you can just bolt on at the end. No, it's got to be baked in from the very first line of code. Then we use segmentation. I love this analogy. Think of it like the watertight compartments on a submarine. If one part gets breached, the flood is contained, and the whole ship doesn't sink. Same idea here. Next, monitoring. This one's simple. You can't defend what you can't see. You need eyes on everything all the time. And finally, and this might be the most important of all, the principle of least privilege. It just means you give every person and every system the absolute bare minimum permissions they need to do their job, and not one tiny bit more.
And when you put all of these principles together, they naturally lead you to the new paradigm for security. A model that's built from the ground up for a world that has no perimeters. It's called Zero Trust.
I mean, that really is the fundamental question we're all grappling with, isn't it? If you don't have an inside and an outside, if you can't just say, this is the trusted zone and that's the untrusted zone, then how on earth do you protect anything?
Well, the answer is a zero-trust architecture. And its core assumption is, frankly, a little terrifying. It assumes that the bad guys are already inside your network. It just completely blows up the whole idea of a trusted internal network. Instead, it forces every single person, every single device, to prove who they are every single time they try to access any resource, no matter where they are.
The entire complex philosophy can really be boiled down to just 4 simple words. Never trust, always verify. That's it.
It doesn't matter if a request is coming from the computer on the desk right next to you or from a coffee shop on the other side of the planet. You verify it every single time. No exceptions.
So this is basically how it works. You've got a user or a device out there in the untrusted zone, which is, well, it's everywhere. They want to get to one of your resources, but before they can get anywhere near it, they hit a roadblock. It's called a policy enforcement point. You can just think of it as a super strict bouncer at an exclusive club. This bouncer checks the request against a list of rules. Is this user who they say they are? Is their device secure and up to date? And only if they pass every single one of those checks does the bouncer open the rope and let them in.
And in the real world, this can be set up in a couple of different ways. On the left, you see a common model where a little piece of software on a person's laptop has to talk to a gateway that's guarding the resource. Over on the right, you see a different approach where one gateway protects a whole bunch of resources in a little protected neighborhood or enclave. They look a little different, but honestly, the core principle, verify everything, every time, is exactly the same.
So as we start to pull all of this together, what's the most important thing to remember? It's that real security isn't something you can just buy off a shelf. It's not a product. It's a continuous process that never, ever stops. All right, let's do a quick recap. We started with this scary reality. Cyber threats are just exploding in cost and complexity. We learned that in the cloud, security is a shared responsibility. You and your provider are in this together. To hold up your end of the bargain, you have to use modern principles like security by design and segmentation, not those old-school digital walls. And where does all of this lead us? Straight to zero trust. The future of security, which runs on a simple, if paranoid motto, assume you've already been breached and verify every single request.
And that kind of leaves us with one last big thought to chew on. We've had to completely tear down and rebuild our ideas about digital security to survive in a world with no boundaries. And as our digital lives and our real, physical lives continue to merge into one, it really makes you stop and wonder, what does the word trust truly mean anymore?